Okay, so to continue, when you do your substitution there, you'll be able to calculate your rate. So it's just a matter of substituting the information that we're given. So this is how you can use the rate equation to actually calculate rate. Let's look at something else. So you can calculate the rate constant from that equation as well. So let's look at an example here. The following reaction was carried out in a lab. You have your nitrogen oxide plus carbon monoxide plus oxygen to give nitrogen dioxide plus carbon dioxide. Calculate the rate constant for this reaction given that the order with respect to nitrogen oxide is second order, zero order with respect to carbon dioxide and oxygen. The concentration of all the reactants is the same, which is 1.5 times 10 to the power minus 3 moles per cubic decimeter, and the rate is 1.17 times 10 to the power minus 3 moles cubic decimeter per second. So we can just substitute this into our rate equation. We have to create the rate equation. So Cannatan's is zero order with respect to carbon dioxide and oxygen. These are not supposed to appear in our rate equation. So our rate equation becomes a rate is equal to K times the concentration of nitrogen oxide squared. Why? Because it's second order with respect to nitrogen oxide. We are told here the order with respect to NO is second order. So that becomes the power in the rate equation. So once we do that substitution, we are given everything else. So to calculate K, we just make it the subject of formula and substitute. So you can try this. And now for the units, it's important that you also calculate the units separately and that your units are correct. So you put the units for rate, which are moles per cubic decimeter per second, and you put the moles, the units for concentration are moles per cubic decimeter, but we're saying squared. So moles per cubic decimeter times moles per cubic decimeter. And then cancel out the moles per cubic decimeter. We now have this. You can find the reciprocal to this. So our units becomes mole to the power minus 1 dm3. This one becomes a positive, and this one is remains as it is, a second. So it's important to be able to derive the correct units for K. Okay, let's move on. We are going to look at another method that can be used to determine the order of a reaction, which is called the initial rates method. So it's important for you to be able to calculate the initial rate of a reaction before you can use this method that's called the initial rates method. So how can you determine the initial rate from a graph? Of course, you can just draw your tangent as before. So I can draw my tangent here where the reaction is beginning, and I can calculate my gradient, and I can find the initial rate of the reaction. In this case, it's 1.70 grams per minute, because we are plotting here the mass versus time. The mass versus time. So once you determine your initial rate, you can work out the rate equation from just knowing the initial rate of an equation. Let's say we want to work out the rate equation for A plus B is equal to, plus C is equal to D plus E. Remember, we can work out the rate equation by conducting an experiment. So we conduct an experiment. So what you have to do is you repeat the experiment several times by changing the concentrations of A, B, and C one at a time in each experiment, and you want to find the effect of changing this concentration on the rate. So you have to change concentrations and plot the graphs. So you need to work out your initial rate as we did in the previous graph, and then change the concentration. So you start, let's say with A, you change the concentration, you see what happens to the rate, but you have to remember the initial rate that you started off with. You change it, so you can double it, you can triple it, you can quadruple it, and see the effect on the rate. So okay, let's look at an example of an experiment and the experimental data that we have here. So here's an experimental data for the following reaction. We have nitrogen oxide here plus chlorine to give this product here. Give the rate equation and calculate the initial rate for experiment 4. So looking at experiment 4, we need to know the initial rate. So how do we go about doing this? So as before, you can work out the order with respect to nitrogen oxide So what you need to do is to compare experiments. So let's look at this example. What you have to do, if you look at you need to hold one of the reactants constant and change the concentration of the other. For example, if you look at experiment 1 and 2 here, nitrogen oxide is constant, but our chlorine has changed here by a factor of 3 from 0.1 to 0.3, and our rate, you can just divide here 0.63, which is your initial rate, into this and see by what factor it has changed. So we can compare experiment 1 and 2. If you wanted to determine to see the effect of changing the concentration of nitrogen oxide, then you have to hold chlorine constant. So if I look at experiment 1 and experiment 3, I see that my chlorine is constant. If I see, I can tell here that my nitrogen oxide has changed. So you want to analyze here, so 0.2 into, this is a factor of 4, and you also want to check by what factor this has changed. Okay, so let's do this. Let's look at what you have to do. So for experiments 1 and 2, you can tell that 1 and 3, nitrogen oxide is quadrupled. The initial rate is quadrupled 2, so you have to divide here your 0.63 into 2.58. So you can see that it is quadruple. So it's proportional, quadruple. So that's first order when you see that happening. So let's look at chlorine. So to work out the orders with respect to chlorine, we need to compare the experiments where chlorine is changing and nitrogen oxide is constant. Like I said, that's experiment 1 and 2. And so you can see here we said it has trebled from 0.1 to 0.3. And what has happened to this? The initial rate, so you go to the rate here. So chlorine is trebled, this one is constant. But what has happened here, we say 1.92 divided by 0.63. We see that it has also trebled. So it's also first order with respect to chlorine. So now when it comes to my rate equation is going to look like this. Okay, so this is how you can determine orders from experimental data and also determine your rate equation. Okay, so where there is missing data, what do you have to do? Let's look at this. So we can use rate equation to calculate missing data. So now that you have your rate equation, you can now go and look at this. So we now have our rate equation here. So first we need to calculate K. K is important. Just pick an experiment and substitute so that you can find K. So we can use any of the 4 experiments to calculate K. So if we use our first experiment there, we can substitute here, and we have the concentration of nitrogen oxide, we have the concentration of your chlorine, you have your rate, so you can calculate K, 31.5. Okay, remember how we calculated the units, right? So now that you have your K, you can now calculate here the rate for experiment 4, the initial rate for experiment 4, by substituting these concentrations. So when you do that here, you can see that your rate becomes 7.88 moles per cubic decimeter. Remember the units here, you have to calculate them separately as well. So -3 per second. So this is how we can use initial rates method to determine the order, to determine the rate equation. So we're going to proceed from here. You can go through this material, and I'll send you some questions so that you practice how to calculate K, how to determine the rate equation, and how you determine the orders from experimental data. So I'll meet you in the next lesson.